All right, Mr. Ahmed here for 5.6. Goal for today is going to be to graph linear inequalities. So these linear inequalities are going to have less than or equal to's, greater thans, or greater than or equal to signs. All right, and our goal for graphing these is to graph the line, and then we're going to shade all the possible solutions for that inequality. So the possible solutions are ordered pairs, x and y, that makes the inequality true. So these first couple questions, we're just going to check and see whether the ordered pair is a solution to the inequality. Again, this is kind of like those first couple problems from solving systems of equations, easily forgotten. All we have to do is substitute it in, see if it's true. So the first ordered pair x and y, we will substitute those values in. So -2 goes in for x plus 2 in for y greater than 0. We have to see if that's true. -2 plus 2 is 0. 0 is not greater than 0. If it were or equal to, it would work, but there's no or equal to sign, so this is not a solution. Bam, draw a line through that. It's not true. On the next one, same process, x, y, substitute in 5 times x. X is -4. Make sure you use parentheses. -2, parentheses, y is -1, less than or equal to -1. So 5 times -4 is -20. -2 times -1 is positive 2, less than or equal to -1. -20 plus 2, we'll simplify it down, that's -18. That is indeed less than or equal to -1, so this is a solution. It is true. So those are yes or no questions, all right? Now on to the graphing. Our graph is going to be a representation of all the solutions. All the shaded region is going to be solutions. Any of those points will work. So what we're going to do is we're going to graph it as if it were a linear equation. So typically, I'm probably going to isolate the y, put it in slope-intercept form. You could find the x-intercept and the y-intercept, but I think we're going to stick with slope-intercept form for the most part. If you prefer to use those x and y-intercepts, you are more than welcome to. The line is solid when it's less than or equal to or greater than or equal to. So if it's an or equal to sign, it's going to be a solid line. It is a dotted line when it's just less than or greater than. So we'll use a dashed line. We can then pick a test point and plug it in to the inequality. Usually we would pick the point 0, 0 and see if that is true. If it's true, we'd shade that. If it's not true, we would shade in a different way. I will also state that we'll talk about a little shortcut for that process as well. So first example, looks like we have x is just less than or equal to -5. So that is a special line. Is it horizontal or is it vertical? X equals is vertical. So x equals -5. I have to go over to -5. 1, 2, 3, 4, 5. Now, a couple things. It is or equal to, so it is a solid vertical line. Solid line. And now we have to shade in all of our possible solutions. So it says x is less than -5. So if I try the point 0, if 0 less than -5, I would say 0 is not less than -5, so we would have to shade the other way. All these values over here, every single one of these ordered pairs, is a solution to the inequality. Next one. Y is isolated, so we're going to use slope-intercept form. The y-intercept is 10, and the slope is -2. M is -2, b is equal to 10. So we'll start by plotting the y-intercept. We have to go up 10. And then our slope of -2 is down to right 1. Down to right 1. Continue that pattern for quite a ways. And this is a dashed line. So since it's a dashed line, I just draw in some dashes here, like so. It is not a solid line because those points are not solutions. Those would make it equal. Now we have to pick our test point 0, 0, and we're going to see if that works or not. So 0, 0 is the point I'm checking. Put 0 in for y greater than. -2 times 0 is just 0. So it's 0 plus 10. Okay. Is 0 greater than 10? I would say no. So that means we don't shade towards it. We have to shade away from it. Now here's kind of my shortcut here. Once we have the variable isolated, if y is greater than, we shade above the line. If y is less than, we shade below the line. In this case, y was greater, so we shaded above. All right, now the next one. You do have the option here of using the intercepts, but I'm going to use slope-intercept form. I'm going to isolate y. So I'm going to subtract 3x from both sides. And I got negative 2y is less than negative 3x plus 8. From here, we have to divide both sides by negative 2. And keep in mind with the inequalities, if I divide by a negative, I have to flip the sign. I'm dividing both sides by a negative, so I have to flip the sign. Negative divided by a negative is a positive 3 over 2. And 8 divided by negative 2 is negative 4. So our y-intercept is negative 4. And our slope m is equal to 3 over 2. B is equal to negative 4. So plot my y-intercept of negative 4. Slope is up 3 over 2. And the line is dashed because it's not or equal to. So I need to draw a dashed line here. There we go. Arrows because it keeps going. So in this case, y is greater than, so we should shade above. Above is here. So I'm going to check my test point of 0, 0 and see if that works or not. Okay? So 0 minus 0, because 3 times 0 is 0. 2 times 0 is 0. Is 0 less than 8? Yes, it is. So that is correct. We would be shading above the line this direction, and we are good to go. That's all we got for today. Have a good one.